Hi everyone, the topic is network maximum flow algorithm. The algorithm name is Fulkerson method. So definition, the maximum flow problem is used to find the maximum amount of flow that can be sent from a source to destination, that is seen in a flow network without exceeding the capacity of all the edges. So take us on simple example. Imagine a water pipeline network is there. So water supply from source to sink, some intermediate nodes are there, right? So each pipe has a maximum capacity. So goal is send maximum water from S to T without exceeding any pipe's capacity. Okay. So this is the basic idea behind this. Start with a zero flow on all edges initially. So no flow in the network. We start with the augmenting start. We start the new flow from source to destination and find the minimum capacity of that particular path, then update the residual graph based on this minimum capacity and stop this process when no augmenting path exists. The current flow is the maximum flow in the network. Clear? So this is one simple example. Here's 6 nodes are there. 0 as source node, 5 as a destination node, sink node. Okay. Here some possible paths are there. One table is here. This table have some values: path, flow, bottleneck capacity, and maximum flow. Then here just write all the possible paths. So here we start from the path 0 to 1, 1 to 3, 3 to 5. So this is the path, right? Then write the corresponding capacity of all the edges. 0 to 1 the capacity is 16. Then 1 to 3 the capacity is 12. Then 3 to 5 the capacity is 12, right? So write all the capacity, find the minimum capacity among these three its capacity. Okay, minimum of 16, 12, 20. Which one is minimum? 12 is 20. So that is the bottleneck capacity. Add this capacity in the maximum flow column. Okay, clear? Then next, so this is then update the residual graph. Okay, then update the value in the residual graph. Okay, how to update the value? Okay, what is the minimum capacity in this path? The minimum capacity is 12, right? So update this capacity, like already the capacity is 16, right? So 16 minus 12, the remaining capacity is 4 here. Clear? Here 16 is minus 12, that is 0. So we cannot carry anything in this edge further. Okay, here 20 minus 12, the capacity is right. So the available capacity of this particular edge is 8. Clear? Likewise, update the residual graph using the minimum capacity. Okay, then what is the next path? 0 to 2, 2 to 4, 4 to 5. So 0 to 2. So 0 to 2, what is the capacity? That is 13. And 2 to 4, 14. 4 to 5, that is 4. So find the minimum capacity among these three capacities, that is 4. So then add this 4 with 12. What is the maximum flow now? That is 60. So 12 with 4, the maximum capacity is 16 now. Then take the next, then update the residual graph. So what is the minimum capacity of this path is 4, right? So using this value, update all the edges in the corresponding path. So 13 minus 4, what is the value? The value is 9. Okay, here 14 minus 4, the new capacity is 10. Here 4 minus 4, the capacity is 0. Clear? Then take the next path. 0 to 1, 1 to 2, 2 to 4, 4 to 5. But in 4 to 5, what is the available capacity? The available capacity is 0, right? So we cannot use this edges further. We cannot use 4 to 5 edge further to reach the C. Clear? So we cannot update this value. Okay, then check the next path. 0 to 1, 1 to 3. But 1 to 3 already the capacity is 0. We cannot use this path also. So we cannot find the minimum capacity of this path. Then move to the next path. 0 to 1, 1 to 2, 2 to 4, 4 to 3. So this is possible, right? Then write all the minimum edges. 0 to 1, 12. So write the updated edges. Okay, write the updated edge. 0 to 1, that is, so 0 to 1, that is 4, right? Sorry. So here write the 4. 0 to 1, 5, 4 years. But we cannot, don't use this path. But what is the 0 to 1 value? That is 4. Then 1 to 2, that is 10. Then 2 to 4. 2 to 4 also 10. 4 to 3, 7. 3 to 5. The updated one is 8. So which one is minimum? 4 is minimum, right? Write 4 here. Write 4 here. Then 16 plus 4, that is 20. So not 23. So 16 plus 4, that is 20. Clear? Then update the graph. Okay. So now what is the minimum weight? The minimum capacity. Minimum capacity is 4. So update this path. So 0 to 1. So 4 is available. Now minimum capacity is 4. So 4 minus 4, the available capacity is 0. Then 1 to 2. So we cannot. Then use 1 to 2, right? So 1 to 2 already 10 is there. So update this path capacity, this edge capacity. 10 minus 4, that is 6. Then clear? Then 2 to 4, 10 minus 4, 6. Then 4 to 3, right? 4 to 3 already the capacity is 7. 7 minus 4, that is 3. Then 3 to 5, 8 is there. So 8 minus 4, now the capacity is 3. Clear? Likewise update the capacity in this graph. Okay. Then next, check the next path. 0 to 2. So here this edge is wrong. The correct edge is from 3 to 2. Okay. Then next path is 0 to 2. 0 to 2, the available capacity is 9, right? Then write minimum of 0 to 2, now the available capacity is 9. So 9 comma 2 to 4, 2 to 4 is 6, right? 2 to 4, 6 comma 4 to 3. So 4 to 3, that is 3. 4 to 3, 3. Then 3 to 5, 3 to 5, the available capacity is 3. So which one is minimum among these 4 capacity? 3 is minimum, right? So 3 is the bottleneck capacity. Add 20 with 3. What is the answer now? 23 as a maximum flow. Then update the residual graph using the minimum capacity value 3. So update this path 0 to 2, right? So 9 minus 3, the new capacity is 6. Then 2 to 4, 2 to 4, 6 minus 3, that is 3 now. Then 4 to 3, 4 to 3, 3 is there. 3 minus 3, that is 0. Then 3 to 5 also 3. So that is also 0. Then just check it out. Any path is available to reach this thing from this source. Okay, just check it out. But if some edges have edges with 0 capacity, we cannot go with that edges. Okay. So here 0 to 1, 1, 2, 3, 0. So we cannot go here, right? We cannot go here because here the capacity is already 0. Then 0 to, here also 0. We cannot use this side path, right? Then here check it out, 0 to 2. Then 2 to 4. So we cannot reach the same because here also 0, here also here 0. So then check this path, 0 to 2. 2 to no. So no more possibilities there because some edges have the capacity 0. We cannot reach the sink. So the final maximum flow is 23. Clear? So likewise find the maximum flow in the network. So first write the path, or one by one you find the minimum capacity of the particular path from source to destination and find the minimum one. Based on this minimum capacity, we update the graph and add it in the maximum flow. In every type you find the minimum capacity, add that value in the initial value of the maximum flow, then finally we get the final maximum flow in the particular network. Okay, so after finding minimum capacity, we subtract that capacity value for the edges present in the particular path. Okay, if any one of the edge have the capacity 0, we cannot use that edge to reach the destination. So no augmented path is available, then stop the process, then write the final result. Okay, clear? Thank you.